What's up, YouTube? So in this one we'll be talking about operators. In mathematics, an operation is a mathematical calculation that uses values, zero or more values, called operands, to produce some kind of value, an output value. The operation to be performed or the function to be performed is usually denoted by some kind of symbol called the operator. So let's get started with arithmetic operators. In C++, the arithmetic operators are the ones you most probably know, so addition, subtraction, multiplication, division, and the modulo operator, which returns the remainder of a division, an integer division to be more precise. So let's put that into context. Here we have a small program in which we define two integers, x and initialize it as 3, y initialize it as 4, and we do operations, arithmetic operations on them. So running the program, you can see here that x plus y, so 3 plus 4 is 7, 3 minus 4 minus 1, 3 times 4 is 12, which is as expected. So the modulo 3 modulo 4 would be 3 because the quotient is 0 of this division, so the remainder would be 3. And if we divide 3 by 4, we get here 0, whereas the expected value would be 0.75. And the reason is that the division here is an integer division because we have two integers here, so the division will be an integer division, and what that means is that everything after the comma, the dot, would be dropped. So 3 over 4 would be 0.75, but since it's an integer division, the 0.75 will be dropped and the output would be 0. To get around that, we need to perform a floating point division, and this happens when we have one of our operands as floating type variable, so either as a float or a double. So let's define here, for example, a float z equal 4, and let's change this here to 4. So if we run our program, you can see here that the output is, as expected, 0.75. In order to use our previous integer y, we can change it into a double by using the static cast function as such. So I'm going to change it to a double this time, and to use it you just type static cast, and here you add the type you want to change it to, and you provide input the variable you want. So here I'm saying I'm going to change integer x into a double and then pass it to the division. So if we run this program, you can see here that the output is the same as expected. Please note that division by 0 can be a bit strange. So here, for example, I'll divide this by 0. You can see here that our program crashed at this division when we were performing an integer division. However, when we perform, for example, a floating point division, so one of our operands is 0, you can see here that it's infinity. So let's say here also we have a 0. You can see this is undefined, not a number. If we have both of them 0, you can see that it crashes. And let's assume that we have x here as integer 0, and we define x by x, which is 0 by 0. You can see that the output becomes 1. So please take care when you're dividing by 0. Another group of operators are the increment and decrement operators. These can be denoted as minus minus for decrement operator and plus plus as an increment operator. And what they do is that they decrement or increment the value of a variable by 1. So let's define an integer x and let's give it a value of 7, for example, and let's decrement its value by 1, and let's print it out on our console. And if we run the program, you can see here that it decrements the value of x, which was 7, by 1 and prints it out as expected. We can increment the value also, so this time it would print 8. What we can do also is we can use it as a prefix, not only as a suffix. So in this case it would provide the same output as using it as a suffix to our verb, to our variable. But the main difference happen when we place them inside some function or some operation. So let's assume we have x++ here inside our cout, and let's run the program. You can see that it prints out 8 as expected. But if we use it as a suffix, you can see that it prints out 7, so our old value. Let's print out x alone after doing the x++. You can see here that it prints out x as 8, so the value of x after this line is 8. So what's happening? So what's happening mainly is that in case we use our increment and decrement operators inside some function, so let's assume we have some function or some operation and we do an x minus minus, this line here would be equivalent to using the old value of x, so our initial value of x before incrementing, and after that we incrementing or decrementing, and after that we decrement the value. Whereas using these operators as prefixes to our variables, this would be equivalent to doing the operation at first and then using this new value for our function or operation. The third group of operators are the relational operators, and as their name says, they show some kind of relation between operands. They are mainly the greater than, less than, greater than or equal, less than or equal, or is equal to, or is not equal to relations. So here we have a quick example. So we define an integer x with an initialized value of 5, and we check, is x greater than 4, is x less than minus 2, is x greater than or equal 10, is x less than or equal 0, is x equal to, so here we have two equal signs, 34, and is x not equal to 4, so to write a not equal we do an exclamation mark then an equal, and what these return is a boolean value. As we said before, a boolean is a true or false value, and for true it would return 1 and for false it would return 0. So in this case this would be true and this would be true, whereas the rest would be false. So if we run our program, we can see here that it returns the expected values. So another group of operators are the logical operators, and as we know from mathematics, some of the logical operators are the not. In C++ it's written as an exclamation mark. There's also the AND operator, which is written as such, and the OR operator, which is written as such. So what we can do with these logical operators is that we can do some logical expressions. So with Boolean expressions we can just write, for example, here let's say x is greater than 4, and x should be, for example, not equal to 2, let's say. And let's group this all together and save, and let's run our program. And you can see that since this is true and this is true, this entire expression evaluates to true. Let's, for example, make this false. So x equal 5, for example, x not equal 5, and you can see this here evaluates to false. We can also use the not operator, for example. Since this is false, now it becomes true, and since this is true, the entire expression evaluates to true. So running this program, you can see that it becomes true or 1. And you can always also use the or operator. This is false and this is true, so together with an or they become true. So you can see it becomes true. And please note that with these expressions you have to follow the De Morgan's law. So once you do a not, this expression becomes a not, and this becomes an and this becomes an not for this expression. So please take that in mind when you are working with logical operations. So you can see here that here it evaluates to 0.